Hello and welcome back. This is a very exciting video because today we are going to complete the first section of this series. When we are done with the video today, the two blueprints that we have deployed will be connected over a DCI link, and essentially you will have a fully functional dual data center EVPN Abstra lab. So let's get started. We'll kick off with a quick review of our lab environment. There are two changes that I would like to draw your attention to initially. First, I did change the color of VN102. The previous color I thought was a little bit too much like the pink that I was using for VN101. So it's green now, easy enough. I've also added two VMX nodes. These are going to be our external routers that we'll use for our DCI. You don't need external routers for DCI. You could just interconnect your leafs. However, I believe that external devices are more representative of what you're going to typically see in the field. I also believe that you'll likely have dual routers that are upstream. I'm skipping that for simplicity and resource reasons. Once you see the workflow, it'll make sense conceptually how you can add two more routers, one for each site, to get that HA if you want to do that. I've already configured router 1 most of the way, not completely, but most of the way. And I've got router 2 here zeroized. I'll take you through the configuration steps for router 2, and you can apply those configurations to router 1. There are going to be some slight differences. I'll highlight those as we go. Host name, IP address, ASN, stuff like that. Let's get started by firing up a connection to each of our routers. Since this is zeroized, there is no password. The first thing we're going to do, well, the first two things we're going to do is set that root password and delete an auto image upgrade. That will keep showing up as we work until we delete it. It is located under the chassis part of the config hierarchy, and for simplicity's sake, we're just going to delete that part of the hierarchy. We'll also do a set system root authentication plain text password, and we'll do capital JUNIPER, Juniper, just like everything else. And I'll do a quick commit here just so I don't see those auto image upgrade messages any longer. Now we'll do some additional tasks. If we look at our system hierarchy, we're going to get rid of this processes tab. Sorry, I said tab. Something changed with my annotation software, and now it's not automatically deleting the annotations when I turn it off and on, which is still throwing me off. Rewinding. There's a section here for processes. It's DHCP trace options. We don't need it, so we'll delete it. Delete system processes, set system host name, and this is ext-rtr2. We're going to set the VMX to what is called light mode. This is a VMX only function. It essentially allows you to preserve resources if you're using this for a lab. Set chassis FPC0 light mode. Just that easy. And let's set up our interfaces. Well, interface at the moment. We're going to be using a transit net /31. This .0 is assigned to RTR1, so we'll be using .1 for this router. We'll also set our ASN. You can see those values here as well. So set interfaces G000.0 family inet address 10.100.100.1/31. Let's set our ASN. We'll do that here under routing options. You can also set this under the BGP configuration. You can use local AS. I like to do this because it spares me having to type it multiple times elsewhere. 65. And this is O2 because this is router 2, of course. That is the baseline config. We'll go ahead and commit and quit and make sure we can ping the other side, and then we'll start building our policy for BGP. Now, something that you should note. I have come to find that when I do this first, maybe one of the first couple commits, and I add a new IP address, I'm not able to assign a requested address. This is simply a matter of time. Just wait. Usually 10, 15 seconds, then this will start working, and then it will never not work again. I don't know what it is about this first layer 3 interface that does this, but be patient. There it goes. Okay. Now, since we're building BGP peers, we're going to start by building some import-export policies that we can apply. This isn't strictly necessary, but it is a good best practice. Since we're on RTR2, we're going to make sure that we're exporting only the DC2 prefixes. This would be the local loopbacks for all the fabric devices, and only importing the loopbacks from the other side. We're going to edit policy options, policy statement. We'll do our import filter first. Set term 1 protocol, from protocol BGP, and route filter 192.168.c. So this is import, so it's got to be 1.0. This is the pool that we defined for loopbacks in DC1 during an earlier step when we were building out our blueprint. We do a /40 or longer, which means that the /32 loopbacks that we are receiving will be accepted. If we did something like a prefix list and we tried doing /24, it wouldn't work because it would be matching against that specific /24. So we do need to use a route filter here. Great, so that's what that looks like. And we'll set a term 1 action of accept, and then we'll set term 2. And in the absence of a from statement, it's a global match, and we'll say then reject. So we're going to say it's okay to import everything from DC1 that's a loopback learned over BGP, and then we'll dump everything else. Up, edit policy statement, export. Essentially, we're going to build something that's the opposite of this now. Set term 1 from protocol BGP, route filter 192.168.2.0/24. Oops, I guess I needed to have a space there. 8.2.0/24 or longer. Term 1, accept. Set term 2, then reject. We've got our export policies in place. Let's work on BGP. Group, and we're going to have a underlay peer that is between these two routers, and then we're going to have the underlay peering that goes to the border leaves. So let's give this a name. Let's call it DCI external. And then we'll do DCI fabric, could be the other one. We'll set the type to external. And we'll set neighbor of 10.100.100.0. Peer AS is 65001. Import, export, family, inet, unicast, peer. Oh, set neighbor, peer AS. Oh wait, I already did. What am I thinking? Ha, perfect. Top, commit, quit. Show BGP summary. Active. Hopefully I've done this correctly. There it goes. Now, we're not going to be advertising anything yet because we haven't learned anything downstream that matches our route filters. But we did want to make sure it was established before moving on. So our next step is going to be making these links. Essentially, the 1 and 2 coming off of the MX is going to correspond with border leaf 1 and border leaf 2, and then it's going to be interface 3 for everything else. So let's switch back over here. Start. If you've not used our virtual machines for VMX, VQFX, you might be noticing that there is a difference in the interface speeds here, 1 gig, 10 gig. Doesn't matter for the sake of Eve or any type of virtualization. It's a meaningless difference. You'll also notice that for VMX, we connect things directly to the forwarding plane, and for VQFX, we connect things directly to the control plane. I don't have any deeper insight to lend to that. That's just how it is. All right, that's 1. 1 and 3. 2 and 3. 2 and 3. See. Since I built these VMX nodes in advance, I should point out one important thing. When you spin these up, you do need to connect this INT interface. You know, it's EM1 for VQFX, it's INT for VMX. It's the same thing. It's the bridge that interconnects the routing plane and the forwarding plane. Now that that's done, we're going to move into Apstra and start building out. We'll start with DC1. And the first thing we need to do is actually create that external router. We'll create it as a generic system. We'll just go here to staged, physical, and then this plus button right here. ext-rtr1, create. Wait for it to show up. We'll give it an ASN. You're going to see a number of red splats over here. Because this is an external generic system, we don't need to fill any of that information in, and we're not going to. We do need to assign an ASN, or else it will assign one for us, and I do like this to be deterministic. This is the local ASN. We'll do the peering stuff later. So we'll get to there, and we'll click Save. And then we'll add our upstream links. So we're already clicked into this, so when I click links, it will... Oh wait, did I take that to the wrong place? Where do I know to go for that? Ha! Oops, topology. So we go to topology, and we've already clicked into this node. Now we click Add Links. Next, select a leaf. You got border leaf 1. This is going to be switch 1, link 1, no lag. Remember, the rule for logical links is that if you have a lag, you'll have an identical name for these logical links. And if you have no lag and you have 2 different links, this name needs to be unique. It says 4, but we know that this maps, because it's 0 index to 0.3, that matches what we've set up. So we click on that and click Add Link. And now we can click here on that. And I do need to change this to switch to -link 1. Just click Add and click on here, Add Link, verify the information over here. Great, and click Create. Now we're going to build an export policy in much the same way that we created policy for the routers that we already set up peering for. We now need to define a policy for the exporting and importing of routes on those border leaves. So we'll go to staged and policies and routing policy, and we'll create a new routing policy. Call this ext-rtr-policy to match our notes. We're doing extra only. You can hover over any of these question marks to see what the different dials mean here. So extra only means that it's only going to pay attention to what I defined here. This is our import policy. So what we want to do is we want to make sure first that we're not importing our own prefixes, 192.168.1.0/24. And this is essentially building a range or longer, like we did on our other configuration. Greater than or equal to is what this means. And this is less than or equal to. So you're only ever going to do one of these. We want to deny that. So we're going to say no. And then we're going to add another one. We could be prescriptive here and we could put in .2. Most of the time what you're going to do is you're just going to do 000. So let's just do a default /0, 32, and then permit. And we only want to advertise out our loopbacks in our export policy. Now we're going to create a connectivity template, and this is going to define the relationship between our border leaves and our external routers. We already have some connectivity templates that were auto-created when we defined these virtual networks. We're going to create a new one here. And we'll call this ext-rtr-CT. And we're going to set up primitives. Primitives are a way of creating almost a flowchart of how you want that link to be built. Conceptually, this can be a little bit tricky to understand, but if you do it a few times, you'll get the hang of it. And certainly when I create a video for getting your overlay connected to a core, or in my case, the router in my lab that gets you out to the public internet, you'll work with these a bit more, and I promise it'll click. So if you have any questions on these, please ask. We basically want to define what that link looks like, and it will create this association. You'll see that here in a moment. So what we're doing is we're building an IP link, so we'll start there. We are going to be BGP peering to a generic system, and we're going to be applying a route policy. And you can see how it builds that relationship out over here. We'll click this gear, and we'll define a routing zone. Tenant 1 is our VRF. That's where all of our clients live right now. The default routing zone is the default route table, essentially the non-VRF part of the router. And since we are defining the underlay connection right now, we're going to put it in the default routing zone, and we're going to make sure it's untagged. Now we can either click on this here, or I can click on this here to do the BGP configuration. Click over here. And we are not peering from the loopback. We're doing interface peering. So we need to make sure we change that on both peer from and peer to. And then the routing policy, we'll point this at the external routing policy that we just created, and click Create. Like our auto-generated connectivity templates from our VNs, we now need to apply these apply this connectivity template to interfaces. So we'll click this little link, and we see here we've got our border rack leafs with our interfaces that we defined in an earlier step, and we'll click Assign to those. And once we've done this, we're actually going to see a couple red splats show up. You'll see that over here. So let's go check that out. IP links to generic. Click Edit, and during the initial phases of building our blueprint out, we defined an external link pool. So we'll apply that, click Save. And this brings up a good question. How do we know what IP addresses are assigned where? We go to Virtual, and we go to Protocol Sessions. We will see the sessions that were defined for the border leafs. We're using the start of the external range that we defined, that pool, and we can see that our local device is .0 and .2 respectively for leaf 1 and leaf 2. We're using ASN 102 and 103, and we're connecting to a remote host that has the ASN that we defined and the other IP in that transit net. So let's go configure our routers for this peering. We'll start with RE1. Actually, we'll only work on RE1 because the other one is for data center 2. I'm seeing RE1 and RE2. This is router 1 and router 2. This is just the node names. The configuration for both of the data center 1 border leafs is all obviously going to go onto RTR1. We'll do edit protocols BGP group DCI _ fabric set type external. We're not going to bother with import-export policies because they're already defined by Apstra for the peers that are on the leaves, and they're already defined on the DCI links that interconnect the kind of pseudo data centers. We could put those policies here, but we're going to save a little time and skip that. Set neighbor, set neighbor 10 dot, what was it, 03? So quickly I forgot 3. 3.0.0 remote. Is that neighbor? Was it? Oh, PRAS, not remote. PRAS 65102. Oh, right? Yes, 102. Okay, great. 102. What else? Family iNet. Unicast. Show. Not much else to it, really. Up. Set neighbor. Oh, oops, I shouldn't have done up there because I was not there to begin with. Set neighbor 10.3.0.2. Family iNet. Unicast. Peer. Oh, so it wants me to Yes, 65103. Now I'll do up and look at all of these together. All right, that looks good. We'll do a top, commit and quit, jump back to Apstra, and commit our changes. Commit, commit. We'll wait and verify this is all working. And once we've confirmed that, we'll go and burn through DC2 and then jump into the overlay, which once the underlay is done is really, really straightforward because essentially you're just peering between the loopbacks on the border leaves. Show BGP summary. Idled right now. Oh, I have forgotten a critical step, and that is defining these interfaces, which is why this is an idle and not an active. So let's do that, huh? All right. Configure set interfaces GE001.0 family INET address 10.3.0.1/31. Interface G0.2.0 family INET address 10.3.0.3/31. Commit and quit. Whoops. kind of matters. Now they're established, just like that. All right, so let's verify that we're seeing what we expect to see here. We can show route receive protocol BGP 10.100.100.1. That's coming, oh, that's, of course, that's coming from the other side. It should be advertising protocol BGP 10.100.100.1. Okay, so the fact that this is advertising the loopbacks from DC1 towards the external fabric router in DC2 means that the import's working as well. So we don't need to bother checking that. And this looks right and healthy. The other work we're going to do is going to be here on router 2. We'll start in Abstra like we did before, and we will build out from here. Staged. Physical nodes, add ext-rtr2, create. Go. Properties, ASN is 65002. Save. Great. Topology, add links next. Border leaf. Oh, switch 1-link1. No lag. U and meh. Oh, geez. Ha! I had to click that first. My bad. Switch 1-link1. No lag. Hello? Oh, I'm sorry. I'm doing this and not clicking add. This is what's happening here. I'm doing switch 1, link 1. I'm failing to click add here, so it's not adding it. There we go. My bad. My bad. 4. Switch 2-link1. Add that. No lag. Click on U. Add link. Create and done. Terrific. All right. Build our export policies, routing policies, create routing policy, ext-rtr.policy, extra only, add, this is for import rules, so 192.168.2.0/32. Pardon me, 24. This is 32. We're going to deny. This means we're not going to import our own prefixes from a remote host, and we are going to accept everything else. Permit. And we're only interested in advertising, exporting our loopbacks. Create that. Build connectivity templates. Add template. ext-rtr-ct. Primitives, IP link, generic system with the routing policy. IP link goes in the default routing zone. BGP. Oh, wait, don't want to forget this. No VLAN. GP peering. We're doing interface peering for this, and we're using the route policy that we just defined. Create that, assign it to links, sort out the transit IPs. There we go. 3.3, assign. Wait for this to go red. and then come over here and assign our external link loopbacks. Pardon me, I said external link loopback. It's late. Just the interface IPs for the external links. And then we hit virtual, we go to protocol sessions, and we get that information. So leaf 1 is 65.202. We've got 10.3.04 and 10.3.06. Great. We're already on router 2. Configure. Let's do the IP addresses first. Set interfaces GE001.0, family INET address 10.3.0 dot be 5/31. Set GE001.2.0, family INET address 10.3.0.7/31. Edit policy options, policy statement, import. Oh wait, what am I thinking? We don't do that here. Edit. Sorry, force a habit. Protocols, BGP, group, DCI underscore fabric, set type external, set neighbor 10.3.0.4, peer AS is 65.202, family INET unicast, set neighbor 10.3.0.6, peer AS 65.203, family INET unicast. Up, show. Just give this a quick glance over. Looks good. That's it. Commit that. And we'll commit this. Let's check on DC1. You can see that the errors that we had there for a minute have cleared as the configuration and convergence has caught up with the intent. We'll see the same thing over here. With that done, we can build our overlays. We do that here under remote EVPN gateways. So let's go blueprints, DC2. Oh, good, we're all green. And gotta remember where to see this. Physical, nodes, links, order rack, leaf 1. Nodes. There we are. Loopback IP. But I'm looking in the wrong spot. Let's make a quick note here. DC2 leaf 1 is 192.168.2.2/32. DC2 leaf 2, I would be willing to bet, is 2.3/32. Let's find out. Yep. Great. And we'll go back into DC1 and we'll collect the same information. Nodes. Border rack leaf 1. Properties. Great. DC1, leaf 1, 192.168.1.2/32. Leaf 2, 192.168.1.3/32. Sorry, my mouse has decided that it is not going to work right now. Back to work. All right. Virtual, remote EVPN gateways. Oh, we're in active. Let me switch over to staged. Virtual, remote EVPN gateways, create remote EVPN gateway. Here we go. Remote leaf. So this is DC-2_BL-1 for border leaf. And we know the IP address of that is 192.168.2.2 slash, I don't even think we need a /32. It's a host IP. ASN is, oh geez. I should have written that down too, huh? My bad. Let's go get that. Nodes. Rack, border rack, leaf 1, properties. Okay. 65.202. That means this will be 65.203. Oh, this will be, pardon me, 1, 1, 65.202, 65.203. All right. Kind of need them both staged. Sorry, that's a long walk to get right back to this point. DC-2 underscore BL1 192.168.2.2 65.202. Don't care about TTL. Probably, I think I just leave the rest of that. This does apply to border rack leaf 1. I'm not going to do mesh. I'm just going to connect the border racks leaf 1 and DC1 to leaf 1 and DC2. You can mesh them together if you want. That's just in the interest of time. I'm not going to bother. Great. And we need to do another one. This would be for DC-2 underscore BL-2. And this is 192.168.2.3 and 65.203. Well, and border rack 2. Create. And now we need to create reciprocal configuration on the other side. There we go. Committing that. Going to DC2. Staged. Virtual. Remote EVPN gateways. Create remote EVPN gateway. DC-1 underscore BL-1. 68.1.2. 65.102. Scroll down. Border 1. Create. And DC-1 underscore BL-2 191.68.1.3 65.103. Scroll down, connect that to local border leaf 2, create, and commit. And wait. Give this a few minutes. We could also log into the routers themselves if we wanted to. Nothing to prevent you from doing that. Actually watch this happen. Unless you forget your password. Just a split second there. I'm like, oh, do I remember how to do this? Summary. And we can see we're established all the way across, which is terrific. So if I do a show route 192.168, we'll say 2.4, which should be a loopback on the spines in DC2. We'll see that I actually have those routes both in the default routing table and also in vxlan.inet, which is terrific. What we want to see. Right now, we're just waiting for these service anomalies to clear, which is almost certainly us waiting for these to come online. There it goes. Alrighty, now the moment of potentially embarrassing truth. Let's get into one of our bare metal servers and see if we can ping around. Bare metal servers. I call it BMS. I don't know why I gave it that name. Obviously we're simulating. This is just a little Linux box. So let's first make sure that we can ping everything that's local in the same DC, 168.101.33. All right, we can still reach the between, what we're testing right now is between this and this. And then I'll try here, here, and here in that order. So I was able to ping the other VN101 host. Let's ping 192.168.102.22, which is going to be VN102 in the same DC. We can get to that. Let's try hitting something over our DCI.44. Can ping that. And 103.55. All right, so we have a DCI up. We have communication between all of the hosts in different VNs. That's it. We're done. Like I said, there will be more videos. This is the end of the first, obviously, large chunk of this series. Let me know in the comments what you want to see next. I am going to do multi-tenancy. I am going to do uplinks from the external routers to my internal core so I can give access to the public internet to these hosts. Maybe service chaining. Just let me know, or I'll choose if nobody says anything. Have a great rest of your day. I am going to go to bed. Take care.